Welcome to the project demonstration of enhanced sizing methodology for renewable sources and battery system in a nearly zero energy building system. So here the main application of this project is, so the wind source and solar source will be mounted on the houses, and the generator voltage will be stored inside this battery pack through this charging circuitry. And also, if you want to utilize that power which was stored inside the battery, we need to utilize that through this inverter circuit, and that is directly free energy for the house purpose. And whenever the storage is available to sell the power to the government, then through this energy meter we are going to provide the power supply AC to the grid. So this is the grid load, means whenever the government utilizes power for the industrial purpose or any commercial purpose, then this load will show the status of the power consumption from this energy meter, and that will be calculated by the microcontroller. Means it will inform you that how much of power was consumed by the government or any commercial purpose from your house. At the same time, if the battery was discharged during the daytime and there is no power supply from this battery pack or from sources during the unseason or night times or rainy seasons, then you need to get the power from the government. So this energy meter will provide you the power supply to your house, and this will indicate the how much of power consumed by you whenever there is no source of power available from your houses with renewable sources. And the microcontroller will measure the how much of energy was consumed by you through this government energy meter, and the net metering system will display on the LCD screen whether you need to pay to the government or the government need to be paid to you. So that is a net metering done by with the help of these two energy meters by the PIC microcontroller. For example, if you consume the 1 kilowatt of power and the same done by the government from your inverter circuit, means daytime we are not going to stay in the house, so the system will provide the power supply to the government if they utilize that, and that will be neutralized from the power consumed by you. If you consume 1 kilowatt hour and the daytime the government consumed 1 kilowatt hour, then it's going to be the zero building system here. And if you consume more than the government consumption, then you need to pay that. Or if you are consumed less than the government consumed power, then the government will pay to you. That readings will be displayed here, whether you need to pay or government need to pay, and the exactly kilowatt hour readings also. So further we are using two energy meters, which is one is for the government consumption purpose and another is consumed by the consumer, and these two relays are used to get the power supply either from the government or from the inverter. So here you can see that S nothing but the sources and G nothing but the grid. So if you place the switch in the grid side, then the house will get the power supply from the grid only. If you place this in the S side, then the system can utilize the power by the house itself. Means there is no need of calculate the kilowatt hour when we are getting power supply from the house itself. Then let us see the demonstration, and we have interfaces two energy meters to the PIC microcontroller at A4 and C0 using this optocouplers which will isolate between the energy meters and the microcontroller. If any high short circuit occurred inside the energy meter, we need to protect the main motherboard by using this optocoupler, and the LCD interface at pin number B2 to B7. So coming to the components wise, so we are using wind power generation which is of 12 volts 1 amp, around 50 watts of power will be generated from this dynamo, and 12 volts 3 watt solar panel, and 12 volt 3 amp battery pack. So in this battery pack we can see the 6 batteries are available. So in that each battery is of 4 volt 1.5 ampere. These three are in series. So we will get 12 volt 1.5 ampere, and this is the 12 volt 1.5 ampere. These two are in parallel. We will get 12 volt 3 amps of output, and this is the main circuit which will convert the DC to 230 volts of AC, and the output of this inverting circuit is input to the energy meter as well as parallel to this relay. So through the relay we can select whether the power should be getting to the home through the grid or from the inverter, and parallel to this energy meter the output is directly to this bulb through this switch, and to this bulb through this switch, and this is a selection switch whether from the sources of the solar or wind or else grid. And main microcontroller motherboard and 16:2 LCD screen. These two are the optocoupler isolation circuits. And here we have provided the another source of charging, that is a grid only. This is only for demonstration purpose. When there is no power supply available from the winds, we can charge this battery also. Just connect the power supply to this transformer. We can see the light indication on this one which will show the status of battery charging. So it will get fully charged in a duration of 6 to 8 hours. And then coming to the demonstration, just on the power supply, you can just disconnect this. While demonstration of the project, no need to connect this transformer, only on the battery pack only the whole system will run. So next I am providing the grid power status, right? So the grid is available power and we are not utilizing that. Now this is the main on off switch to run the kit. So welcome to the project, and next it will display that home and government 00 kilowatt hour. Now I want to consume the power directly from the solar panel. Then see, there is no like output from this one. Then we can see the home is, wait a second, right, you can reset that. Right, now we can see, now we are consuming the power directly from the battery itself, not from the government. Now if you want to consume the power from the government, then you need to switching this to the grid, and we can see the brightness bit increased, and you can reset that. Yeah, LCD we can see. So the readings will be slowly increased. So as of now we are demonstrating only we are going to getting the power from the government, and the government is not utilizing the power as of now. Just we are going to showing the reading. The home is consuming the power in kilowatt hour, right? We can see that the home reading is going to be the 0.006, and now the consumer need to pay the so-called net worth of 0.006 kilowatt hour unit readings. Based on the price per the unit, we need to pay the bill to the government as we are consuming the power. Now next I am not utilizing the power from this one. So now the reading is 0.05. Now on the power supply to this government from the inverter, means the government is consuming the power now in the day times. Okay, right, so it is given to this one. Slowly, as previously, it will increase the readings. Right, so you can see, just replace this switch for providing the more power consumption from the government. So you can see that government as of now consumed 0.018, but the home consumed 0.50. The remaining difference we need to pay to the government. That you can see that consumer need to pay that. But slowly we can increasing that. The power consumed by the government, the net is slowly decreased. Right, now see that government will pay you 0.046. Now you are getting the money from the government, as the government is consuming the more power than you consumed from the government. Parallelly, we can utilize the same thing. See here, we are utilizing the power from our home only without the government, and the government utilizing the power parallelly. If you switch that to again, then the government will get in the power supply. Right.